Hello, welcome. So today we're going to share a second question on functions of graph. Earlier in the previous video, we shared about how do you actually sketch out different kinds of graph. If you have missed that out, do check out the video. Okay, it can help you, benefit you for your end of year exam. So now for question 2 here, it is to sketch out another kind of graph related to, in relations to how fast you actually fill the water up. Okay. Now, in this question here, a lot of students might think that when they ask you to find out how many seconds will the hemispherical end be filled, they might think that you have to find the volume of this hemisphere, right? But then if you do that method, right, probably what you need is you need the volume, okay? And then you also need the rate of the filling. So if you use volume divided by rate, then it will give you the time in seconds, right? But then this is not the kind of question that involves rate. I mean, even if you find a volume in the hemisphere, it doesn't help you link to the time itself because you are not given the rate, right? What we need to know is that the rate is constant and is based on the comparison in how much the ratio of how much water is inside the hemisphere. When you compare that to the volume inside the cylinder, that's where we know how to split up the seconds into two different parts, okay? So we will still write out the general formula for the hemisphere, but take note that both hemisphere and the cylinder uses the same circle, okay? Same circle. So for this hemisphere, the formula is 2/3 pi r cubed. The whole sphere is 4/3, so this is half of it, just 2/3. And on the right side, you're going to put it as a ratio of the volume of hemisphere to volume of cylinder. A cylinder doesn't have any fraction, it's just a simple pi r squared times h, okay? So that's why we throw in a number. In fact, you can you don't need to add in the value of pi because the pi can be cancelled away, right? And at the same time, the only thing that we have left is basically the radius. This is divided by pi first, right? All right, so we create a ratio in final answer in the simplest form. It's 18. And this is 108. And if you put it in simplest form, you can use the calculator for that. Just type it in a fraction. Type it as a fraction. And when you press equal sign, it will convert to the most simplest form for you, which is 1 to 6. Okay, that means that the amount of time needed to fill the hemisphere is also going to be in the same ratio because the volume wise is 1 to 6, means the time needed is also 1 to 6. Okay, so the total of 15 seconds basically represented by the total units of these two, since it's the total time needed, right? So we're going to use the units to begin. We say that 1 plus 6 is 7. Now in this question, some students might get stunned because they see that, hey, how come it's such a weird number? But remember, even timing is a form of measurement, and it's okay for you to have a weird number, right? So 15 divided by 7, this means that the hemisphere needs 1/7 seconds to fill. Okay, and in round of 3 as that, there's answer for 8. Okay, then next we have to fill the depth of water. So we know that after 2.14 seconds, the hemisphere part is going to fill up, right? So the first marking is, of course, when we fill in the water, it will start to fill from the bottom. So that's why the first thing you got to label is the hemisphere itself. Just estimate will do, since it's not an exact value. Take it as 2.14 here. When you finish filling up the hemisphere, this means that your depth is not finding volume, it's about the depth. The depth will be 3 centimeters. So make sure it hits the height of 3 centimeters. Somewhere here. Okay, before you continue. Now the next part of all of them is going to be just the cylinder. And the cylinder will have this flat, take note that it's just a constant uniform base area throughout, like the circle of the base from the top to the bottom doesn't change at all, right? And when you finish filling out the cylinder, you will add in the additional 12 cm. So if you plus the 12 in, by the time you finish at 15 seconds, okay, so this is 12, this must be 14, 15 must be in the middle here. It will also reach the height of 15 cm. So make sure it hits that number. All right, so this part here is simple. It's just going to be a straight line. I don't have a digital ruler with me, so it's pretty hard for me to create the straight line. You get the idea, huh? So it's a straight line here. And then for the front part, because the amount of surface area is increasing, like from a small region that you have to fill, and then when you fill up this part, it becomes like this big, and it becomes bigger and bigger. You know, the circle gets bigger and bigger. So this is known as the increasing area. All right, and for this kind of figure that have an increasing area, you got to think about the leaf shape. If it's a uniform area, just like the cylinder we just drawn, it's going to be just flat, diagonal, I mean a straight line, right, going up. But of course, if let's say the surface area gets smaller, it becomes faster and faster to fill near the top, isn't it? So it's going to look like this kind of shape, where the slope increase in gradient. And finally, when the area increases, which is in this case, right, it should resembles like the filling becomes slowed down, okay, because you need to fill a larger amount of space as you go up, so it takes more time to fill the upper part than the lower part. So make sure that this is a kind of cave that basically has a decreasing gradient this way. Okay, and then the rest is a straight line. That's all for today. Thank you for the lesson.